So from here, I will take over the moderation for a short while, because our next speaker is actually Jimeno Fonseca. So Dr. Jimeno Fonseca is the project coordinator of MuSES, and his research interest focuses on modeling and data analysis. He explores how environmental changes impact demand and supply of energy in cities, with projects ranging from the building scale, from buildings to transport systems, and from the cities to regions. In the MuSES project, he is also contributing to the development of the open source energy analysis tool, City Energy Analyst. And this is what the next presentation is going to be about.
All right, thank you very much, Gabriel, for the introduction. So now is the time. I would like to talk to you a little bit more about what this City Energy Analyst tool is all about, and how the different sub-projects of MuSES basically map to this research and development effort we have done here at the Future Cities Laboratory. So as its name basically states it, the City Energy Analyst is a tool to analyze the energy systems of a city. Basically, that's the vision we would like to portray. And I would like to start this presentation by showing you basically what the City Energy Analyst does. So what we basically have created is a platform where you can easily create new projects about exploring technologies for improving the performance of a district. And in many of these projects, the first, let's say, idea is, or the first barrier that we wanted to overcome is the idea of gathering data about the built environment, building those building information models that help us to analyze different technologies. So we have created different tools that help us in no time gather information about the technology, the weather, the terrain, also buildings in cities, using open sources of data as much as possible, as well as our own databases. And with this, practically the tool allows any user, it's free to use, it's open source, to indicate where is the location of their next planning for a new district or energy system. This is executed basically in no time. And what we gather for this is a completely new building information model of the site. Just to clarify, I think for many people who are in the building domain, are really used to dedicating potentially several months to years. At the beginning, it took us even years to get up to this stage of collecting data with enough clarity so we can simulate and predict how energy systems perform in different buildings. So what we did with the City Energy Analyst is to help users to get access to this information with ease, at the fastest pace as possible, and helping to also edit it and also transform the district as they know the best it looks like. We're also creating different databases so we can take a look at the typologies, at the different standard ways in which buildings are developed nowadays. For now, it's restricted to Switzerland and Singapore, but we believe that this may as well approach, approach different contexts too. So one important aspect that we introduced is the idea of schedules. I think that's something that makes a connection to what Gabriel had to present at the beginning on how this modularity and diversity of schedules can highly affect the demand. So we make sure that we created different interfaces and give this flexibility so energy engineers can analyze multiple diverse profiles of occupancy in buildings with ease. And with this is just a presentation of how we launch simulations, which depending on the type, on the different more than 20 plus tools that we have in CA can last, we can get an immediate response of what is going on. So after that, this is here presented in our dashboard. Basically, the interaction goes simulate and then obtain results in terms of graphs. That with the time we have condensed up to a point that we can understand what are the patterns of demand of future or existing, in this case, or future districts. The time resolution that most energy engineers and also planners need, which could be hourly resolution as well as months or even years, depending on the type of analysis you need. And what we took a lot of care is to understanding the different type of energy services that are used in buildings nowadays and in the future. Because as Xianshan, for example, presented, the key of new technologies such as hybrid cooling technologies is in being able to separate different type of processes that are used to supply services in buildings. For example, dehumidification from cooling as an example. And with that, we take the care to actually split and give the user this understanding on what will be the future energy services of a city. We also took a lot of care of understanding what will be the potentials of solar generation, as well as other sources of renewable energy. As we see, like the future of low carbon cities will be based a lot on these technologies and understanding their potentials with this. Also, we implemented some aspects of optimization here in this case, where we can analyze. I mean, I can resonate with what Francois said at the beginning. We're not exploring how to get the best solution, but rather the most important solutions worth considering. So for this, we have created different algorithms that allows you to search in the wide space of multiple solutions and technologies, what would be the most likely applicable to your site that can reduce either the costs, in this case, the emissions, or also the capital investment costs. We pay a lot of attention into understanding what will be the cost for centralized as well as decentralized technologies, which we know play a role in terms of the economics of a scale, which I will be talking about more in a few minutes. So of course, some of this information is sometimes not enough for energy engineers. So we try to also get really detailed information regarding, for example, the dispatch profiles of these future cooling or power plants at the district scale, but also helping them understand what could be the type of infrastructure that you're building for that scenario. How is it going to be operating during the day, and also understanding if it's going to have certain implications into how the power grid or the surroundings work, here by understanding what would be, for example, the needs for extra ramp-up capacity at different hours due to the integration of PV technology in this case that you can see here. Good. And then I think I can resonate to the aspect that Francois Maréchal mentioned, that at the end of the day, we have to take a decision from all these multiple, let's say, criteria, multiple scenarios. So we also try to introduce different methods to do a life cycle analysis and multi-criteria analysis of the site. So it can help users to better understand what would be the emissions across the entire life cycle, also the cost, and compare different scenarios of technology, including district heating, as well as district cooling networks as they are presented in this case. All right. So with that being said, I'd like to then talk a little bit more about what is the motivation behind the City Energy Analyst. So I think Arno introduced to us this at the beginning of the entire afternoon, of the need for new tools, for new ways of analyzing how to get to this low carbon society or low carbon neighborhoods in the future. And it's to say that there are many alternatives to do that. Please bear with me if I'm talking about this in a really high level. But potentially the things that we can do to arrive there, the alternatives that we can explore, can stem out from controlling the demand, the development of buildings. I think Xiumin talked a little bit more about that during this new way of looking at energy and the city. But if you look at ways to control the demand, to retrofit buildings, to change windows, lights, etc., you will see that there are many options to do it so, right? There are many technology manufacturers, as well as multiple ways in which you can configure buildings. Basically, the options can be very, very infinite, very, very, very high. Now, another thing that you can do if you look at from the other side of the spectrum is to control the type of supply of technologies used in districts. And for this, also, as we saw in the last presentation of CA, you can create multiple options about technologies, about which buildings to connect, which ones to maintain decentralized, whether using batteries, whether using storage, and if so, what type of size of this storage, what type of manufacturer, what technology exactly. And acknowledging this, we will have a really high bandwidth of options. So how to actually cut the line through all these aspects? This remains an open question. Now, the third aspect that you can do, and something that I think Shanshan quite strongly pointed out in her presentation, is the question of scale. And I think one of the main motivations of this MuSES project is to understanding that if we can apply technologies at different scales, you can benefit from economics of scale. But if you overdo it, you can have the economics of scale, basically. When you have to put a lot of capital investment, once again, the mass production of an item basically increase, in this case, the production of energy. So the point is, okay, let's say we can change the scale of our technology. So what is the most efficient scale? So a big warning that happens here to designers and also planners is that usually cities as well as districts, communities have a low budget, limited amount of natural resources, and very optimistic goals, right? We would like to be carbon neutral. We would like to obtain 0 emissions by 2030, 2035, and sometimes sooner than later. So under these constraints, we need new analytical tools that help us to basically get this red thread of options that can help us to build these low carbon neighborhoods in the future in an affordable way, right? So this is one of the main motivations of CA, and I think the main objective that we took during the last 5 years of doing this is that, as Arno presented at the beginning, we had a lot of projects of software projects came up from research who didn't make it through the day of the light of the day. So we wanted to change that, and we wanted to also challenge this project to make it to a technology readiness level really high in the way that it can be used by real people back into the operations of city or planning cities, right? And we understand that there is a need of this because we can support the hundreds of districts or low carbon districts that are going to be planned in the next coming decade. And there is an intense need that we can move this research into application as soon as possible. All right, so to do this, I think this is more than methods. I would like to talk to you about the success factors, what I believe help us to come up to this point. And the first success factor I would say is that we got an extraordinary agile development team, which is basically fed by the multiple domains of expertise at MuSES, which we had the chance to actually talk to them in the last few presentations. And I think it was important to get this professionality at the level that we could compete like any other startup company or company in the tech sector developing software. We have to really reach the level so we can actually make sure that our project will not basically be sitting behind after we leave, but actually has a legacy, can be literally used by people beside us. So we adopted that agile structure, which will be fed by different projects at different capacities. And with that, we not only implemented people in Singapore, but I think one of the most important things is that we managed to create a community of people taking different roles to support the project, from development, from customer teams and operations, from sponsoring, that help us to get up to this level of development in really short amount of time, acknowledging that most of the researchers are dedicated to producing high quality research, as we saw it in the last presentations. So I think it was very, very good and a success factor that we were able to set up this community and this family of the city energy analysts. And of course, one of the key points of success is that we try to, of course, keep the fit all this high quality of engineering with increasingly better ideas about UX design, right? And business development. That is part of the work that we have done during the last years of making people more aware of the existence of these tools, and then help them basically change the processes they do today so they can develop these low carbon cities in no time. And that was part of the approach we took to make this possible. So a big warning, what was happening with all these approaches we took was that we actually produced very fast and a very high quality the city energy analyst. And I think that helped us to just take our chances of success to the limit. All right, so now I would like to talk to you more about the impact we have had in the last years. So I think one of the most important ones had to do with education. At the beginning, we talk about the need to actually change mindsets and incorporate these ideas on how to plan in not single buildings, but entire districts, multiple technologies, supply, demand, and also scaling, and put all this together in a meaningful way. So we created an executive program, first of its class, that has attracted more than 40 practitioners nowadays, who have flew in the past from their own locations in North America, Europe, and also Southeast Asia here in Singapore to meet us for a week and get trained about the detailed aspects on how to study the strategies for low carbon cities using the city energy analyst as a framework. Now, another point that I think we're really proud to say is about the new graduates and the career development that we have that has been manifested in the wealth of different PhDs and master students, as well as new assistant professors who at certain point of time made part of this city energy analyst community. And which we think that at certain point, this connection to pushing the limits to this new field basically help that we are proud to say that all of our different contributors have made it into very good positions and very good career development, acknowledging that we have an entire future ahead, be it in practice as well as in research for exploring this concept about multi-scale energy systems in the future. Now, moving on a little bit from education, we talk a little bit about research. And I think one of the great impacts about the city energy analyst is that it has served as a catalyst for bringing different multinational projects together. Apart from multiple publications in the field in high impact journals that use the city energy analyst for the research, we have came across different research projects which are tackling key questions about the development of cities in the future. Here to say as an example, many of these projects we're going to be, first of all, hearing about a little bit more during the next session. But if I have to highlight one, could be the Cooling Singapore project, which is creating a high influence in the agencies in the term of how to combat urban warming and mitigate it in the future, and using the city energy analyst to respond energy-related questions about mitigation strategies for urban warming. So I see that the city energy analyst has also enabled other type of research, even if it is outside of the scope of CO2 emissions. Now, I think the third point, the most important, is talking about adoption. I think we have had the chance to get different users on board at different qualities, having people, for example, in Canada, exploring how climate heating seasonality in districts will change in the future due to climate change, and using the city energy analyst to understand, for example, when the new policy for heating or cooling buildings should be promoted, basically understanding on what day of the year we should start heating or cooling buildings policy-wise. And this can make a strong change in terms of energy conservation strategies. And we're happy to say that city energy analyst is being used for this type of applications. There are many more coming from around the globe, but if I had to highlight one more, is some of them that have surprised us during the years. And it's, for example, one of a professor in Poly Lisbon, who actually has taken all this open source material we have developed, and he flew himself to France, gathered professionals and also students from Europe and Africa, brought them together to his school, and then teach them about using the city energy analyst and the analysis of urban energy systems as we basically portrayed it. So that's something that has brought us a lot of happiness throughout the years. But also, I have to say that it is not possible without thinking about our users, main type of users like students who are looking at how to use this optimization, this stochastic optimization and data analysis capabilities to better understand what is the impact of technology in cities. We also have practitioners, for example, in Singapore, who are very interested in using the tools for creating thermal and hydraulic networks, something very practical that they use for the camps. In this case, for the example of this type of practitioner. But we also have project managers, those ones who are leading the transformation of districts and who are who basically would like to better understand what are the investment costs, the missions of the district, and how to improve it in the future. So needless to say, I mean, we have a considerable amount of, I would say, downloads and especially users that we can address, that we can connect to. This looks like a small number, but in this type of tools and the types of ecosystem, it's still something that I think is considerable and important. And that is something that we very appreciate and try to maintain. All right, with that said, I would like to close this presentation. I thank you very much for your attention.
Thank you very much, Jimeno. As usual, now is the time for Q&A, so please post your questions into the Q&A session. And I myself have a short question in the beginning. Just you mentioned just right now that you have downloads, 1,000 downloads a year. Maybe some of the users are interested how to download the tool.
All right, yeah, that's a good question. So the best way to download the tool, you can go to cityenergyanalyst.com and you can click on try and just let us know a little bit about you, just your email, so we can come back to you if there is a problem. And you can download it free of charge. Basically, it's open source as long as you want to use it, including the source code as well as the binaries.
Okay, thank you. So there is one question in the Q&A from Anonymous. And the question is as follows: where can we find example projects or scenarios? Are there examples for Singapore, considering district cooling instead of heating?
All right, yeah, that's a good question. So we, in our repository where we develop the City Energy Analyst, you can go to cityenergyanalyst.com and click in the button called GitHub. You can look at all the root folder of the entire tool. And there is one folder called examples. In that examples folder, we have some characteristic neighborhoods that can actually get you on board of using CA, both that are applicable for Singaporean context as well as the Swiss context.
Okay, thank you very much. There is a follow-up question also from Anonymous, very specific to software development. How do you ensure that the code is up to date with the ever-changing Python packages?
All right, yeah, that's a good point, a good question. So I think that's pretty much a matter of continuous development and maintenance. Needless to say, even if it is an open source project, the sake of having a community is that we help basically the community to get started on how to use the CA, but we also embrace this community in the way that they can also help us to build the tool and maintain it in the future. And that's part of the beauty of having this open source approach, right? Of now that we have basically our PhDs and myself developing and a couple of our developers, we have more than tripled that community in terms of users who can contribute and can help us to update, be it to new packages or to solve bugs or to have new features into the tool. So I think there's no easier question to that. You just need to do it. You need to keep processes in line of continuous integration, good testing, the different approaches to that, and keep the versions and keep compatibility at all times. Every time we do releases, We do releases every 2 weeks, so that helps us to maintain compatibility at all times. And as part of the management process, we deal with the tool. We take it as a software development project rather than only research.
Okay, thank you. So the next question is from Paul Westermann. He asks, does the CEA allow to integrate the metered energy data to calibrate the parameter of a district?
Yeah, that's a great question. So for the framework that we developed and that you can download, there have been already a couple of projects which have explored the aspect of calibration. Some of them using what we call the bias theorem of calibration, which doesn't provide you one single endpoint estimate, but more of an entire probability curve of where your parameter is more likely to be according to measured data, as well as other approaches just looking at a grid search of the multiple combinations and understanding what is the one that fits your data the most. So these approaches, you can find them in the legacy folder of CA. It's part of the research projects that many people have contributed to the years. At this point, due to the type of computational power that these calibrations need, we don't provide it into the main framework because it will change the type of workflow and will not benefit most of the users. We're looking at other ways of how to optimize it, do it faster. We're very happy if you would like to contribute, definitely, to do this.